Okay, this is going to be notes for lesson 12-4. We are going to be seeing secant lines. And first of all, what is a secant line? Secant line is basically a line that goes through, intersects a circle at 2 points. So there are tangent lines that just hit the circle at 1 point, and then a secant line will cross it at 2 points. So this is a secant line. And just some more terminology. This, just the inside endpoint to endpoint, that's called a chord, as we have already learned. But if it goes on forever, we would call that a secant line. So what we're going to see is two intersecting secant lines in the middle of the circle, or even outside the circle, lines inside or outside the circle. But I actually want to go over everything that we've seen up to this point, because this is where this chapter gets hard. There's a lot of different formulas and positions of the angles and the arcs. So if your angle is in the center, it has a degree, that's 90 degrees. The arc that it intercepts, they are flat out equal. So an angle from the center is exactly equal to the arc it hits. If you pull it back, this is called an inscribed angle. This is an angle that is on the circle, and it is half the arc it hits. So if it's 90-degree arc, then if you're on the circle, an inscribed angle, you were half 45. What we're going to see today are angles that are inside the circle, just like angle X, but not in the center. So the center is right here. Or you're outside the circle. Now if you're inside the circle, if I look at angle X here, you could tell this angle and this arc have a relationship with each other. But at the same time, based on vertical angles, if this is angle X, so is this. But this angle X is pointing at this arc here in pink, which it could be a totally different measurement than this one here in yellow. So if you have an inside angle X, whether it's here on the left or here on the right, since they're the same, the formula is going to be angle X is going to be 1/2, and you're going to add the two arcs, the yellow and the pink arc. The yellow and the pink arc. You're going to add them. So if it's 100 and this is 70, you'd add 170 and then divide by 2. Take the average of the yellow and pink arc. You're also going to see formulas where the angle is outside the circle. Now this angle, when I see it extends, it hits two arcs. It hits this bigger arc here in yellow, and it hits this inside arc here in pink. And to figure out angle X here, you would take arc minus arc. You take the yellow arc minus the pink arc, and then take half of that. And that's going to be the two main formulas that we're going to see in our notes in just a moment. But you're going to see angles outside, inside angles, angles that are on the circle, angles that are in the center of the circle. So let's deal with these ones that are inside and outside. So when you have an angle inside, like angle 1 here, inside the circle, what you do here at angle 1 is it is 1/2 arc plus arc, and I'm going to put a plus sign here in red. In this case, arc X plus arc Y, and then add it and take the average. That's inside the circle. You're going to see angles that are outside the circle. This next group there, let me focus that. These are outside the circle. You're going to figure out the difference, not add, you're going to figure out the difference. So, angle 1 on the outside, angle 1 on the outside, angle 1 on the outside, it is 1/2 arc minus arc, the difference. Okay? There's also going to be another section that deals entirely with segments. You got crisscrossing segments here, and this wouldn't be in degrees. This is like how many inches are these guys here and here. You've got lines that crisscross, chords that crisscross inside. You've got lines, secant lines that crisscross and they meet outside. Basically, if you look at this, this is simply green segment times green segment is equal to red segment times red segment. Red segment times red segment. So A times B will equal C times D. This other one, where you're outside, and these two both represent lines that meet outside, there's a lot of gobbledygook here. It says Y plus X. This is the entire line. I'll put the whole line times W, which is the outside portion, is equal to y plus z, which is the whole line, times the outside portion. And that's the same with this other guy here. The whole line times the outside portion, the whole line times the outside portion. So there's going to be the green line, the whole green line times the outside portion of the green line, and then there's the whole line in red times just the outside portion there in red. Okay, that's the same with this one here. Okay, let's try some of these. Now this is another concept here, but this doesn't deal with angles and arcs, it deals with segments. Let's do number 1 and number 2 here. Number 1, what is the value of arc W here? Arc W. Now what we have here is an angle that meets outside, and when it's an angle that meets outside, the formula is the angle is equal to 1/2 the arc minus the arc. So when it's outside the circle, outside angle is equal to 1/2 arc minus arc. They actually give us the outside angle. That's 70 degrees. 1/2 arc W minus the smaller arc 110. And we would solve this here. Let's multiply both sides by 2. Cancels out that half. Kind of running out of room here. I'm going to come up here. 2 times 70 is 140. This is W minus 110. And I'll add 110 to both sides. So this is 110 plus 140. W is 250. Angle on the outside is equal to 1/2 arc minus arc. The other way to do this, and this is really simple, and this is actually why this is not a particularly good question here, is you can ignore the fact that this 70 is here. The fact that this red line here is 110, and this is an entire circle, you could have easily just gone an entire circle, 360, minus the 110, you would have gotten 250 degrees. Same answer, 250, 250. Okay. Number 2 here deals with the segments. This is an outside segment, so it's going to be this one right here. And I always just mention it as the whole line times the outside portion is equal to the whole line times the outside portion. All right, so when we look at this picture here, the whole line here in green is going to be 20 plus 14, and then the outside portion will be just 14. So it's the whole line times the outside portion, and then that will equal the other segment here, the whole line in red, which is x plus 16, excuse me, times just the outside portion, which is 16. All right, and we're just going to need a calculator here and figure this out. This is 34 times 14. This is 476 on here. This is distributive property 16x. 16 times 16 is 256. This is getting a little ugly here. I'm going to minus 256 to both sides. 476 is equal to 16x plus 256. I'm going to minus 256. This is 220 is equal to 16x. I'm going to divide by 16, and I get 13.75 is the value of this x here. Okay. So with segments, this is not angles and arcs. With segments, whole line times outside, whole line times the outside portion. And we're going to skip number 3 here.